everyone. This is Anusha. In this video, I would be exploring the most important topic of databases, that is joins. In real-world databases, data is stored in a normalized forms. It is organized into multiple related tables to avoid redundancy and maintain consistency. So, to fetch or analyze complete data or information, we use joins to bring these related tables together for querying and for preparing reports. There are 6 main types of joins, that is inner join, left join, right join, full join, cross join and self join. Let us look at each join with a simple example. So this is first we look at inner join. Inner join is a join where it returns all the matching rows in both the tables. For example, here we consider customers table and here an orders table. So if we join these two tables using inner join, so we would receive the output as the matching rows between the two tables. That is Alice customer ID, this is matching with this order ID. So this is returned. Bob customer ID is again matching with this order ID. So this is returned. But this Charlie customer ID or name, it is not matching with any of the order ID. So those row is not returned. So because it is inner join, it will only return the rows which are matching in both the tables. Next we look at the left join. Left join is returning all the rows from the left table and also the matching rows. We'll demonstrate with example. Now we have a customers table and orders table. The matching records are Alice and Bob which are displayed. But here Charlie is also displayed because Charlie here customers is the left table. So in left join, even there are no matching records. In the left table, whatever record is there, that record is displayed with the null as value. In the same way, the right join also, if we give join the table with right join, you will get the matching rows as well as the rows in the right table which have no matching row in the left table. That is, here the order number 103 doesn't have a matching row in the customer table, so it returns null. In the same way, a full outer join returns all rows from both the tables with the matching records also. So here in my SQL, there is no direct full outer join. So what I am doing is I am combining the output of the left join as well as the right join to get the full outer join. So now here you can see we got the matching records as well as the table Charlie which doesn't have any matching record on the left table, that is also displayed, and the order ID 103 which doesn't have a matching record in the left table, but that is also displayed. Next we look at the self join. Self join is a table which is joined with itself. Like this is the employee table I have. So here I am joining the employee table with again the same employee table, but here I am giving the name alias as E1. Here I am giving E2. So this is the same employee table here and here. And we are joining the same table again with the same table to get the employee manager hierarchy. So we are seeing the example of an employee manager hierarchy to understand self joins. So here we can see the query. Select event.employee name. From here one employee, this employee name is selected, and E2.employee name, from here this employee name is selected, and we are joining the two tables with E1 and E2, and we are giving the condition even.manager ID is equal to E2.employee ID. And here I am using left join because I want to display this employee name with the manager ID as null, because the employee with the manager ID null in the sense he is in the top position or a CEO of the company, and I want to display his name too. That is the reason I gave left join. So if we look at the condition, so event.manager ID, so if we come at Mike, it is 1 is equal to e2.employee ID. So here the e2.employee ID is 1. So here from here Mike is displayed, and here this employee ID is John. So John is displayed. In the same way, Sarah has a manager ID 1, which is again the employee ID of John. So here Sarah is displayed, and again here John is displayed. In the same way, David has a manager ID 2, which is the employee ID of Mike. So here David is displayed, and here Mike is displayed. In this way, we are getting the employee manager hierarchy using self join. Next we have cross join. Cross join is nothing but the Cartesian product of all the possible rows. So it returns all possible combinations of rows between two tables. So for example, we take a teachers table and the classes table. So if we want to schedule for every teacher to teach for every class, then we take a cross join. So we'll get all possible combinations of teachers and the classes. So if we do the cross join of these two, so we'll get all possible rows, like Mr. A to Maths and Science and Mr. B to Maths and Science. So if we try to understand what is the difference between full join versus cross join, full join returns all records from both tables, whereas cross join returns all possible combinations of records from both tables. Here we can see this is a full join where you are getting matching records as well as the non-matching records from left table as well as right table. But here when we cross join both the tables, it is giving every possible combination. So this is what is cross join for every record, that is Charlie, Bob and Alice. It is giving every possible combinations. So while joining two tables, we need to join them in such a way that the join is optimized and it gives good performance. So while optimizing joins, we need to understand certain points, like we need to join only what we need. It's like we should stop selecting select star, because we need to specify only required columns to reduce IO and memory load, because the more number of columns you specify, the more number of operations it would take. And we need to join index. If we are indexing columns, then we used to do the indexing. We have to create index on the join keys, because when we create index on join keys, it matches rows instead of scanning entire table and then quickly get your matching records. We need to avoid full join if possible, because they are costly. We can use union when suitable. In the same way, filter early. Like before the joining is applied, if we could filter only the necessary rows and remove that unnecessary rows using the filter conditions, it would reduce a lot of IO operations. We need to even make sure that the data types of the joined columns should be same. If not they are same, then the SQL would force the conversion, but that forcing conversion will take time and it will slow down your query. We should use explain to analyze join. We should by using explain, we would understand like how much time or how much scans it is taking. So we should check for using temporary or using file sort kind of words, because they indicate performance inefficiencies. And then keep join order logical. Yes, if we are joining with multiple tables, we should make sure that we are joining in a logical order, so that the complex queries would become a little simple and efficient. And there is like normalize but don't over normalize. Like due to normalization, every data is separated and stored in related tables. But sometimes while writing query, we need to understand like if getting that data directly to the table is better, or joining that table, because too many joins can reduce the query performance. So that time sometimes denormalizing or getting that column directly into the table could be much efficient. So we need to understand the balance between the normalization and the joins. Avoid functions on join columns. Yes, again on the join conditions, we directly applying functions could increase the IO operations for every scan. So we should try to avoid that functions, and we should try to calculate that beforehand, rather than directly applying those functions on the condition. And then use temporary tables or CTAs for complex joins. For complex joins, what happens is because of joins, it might lose the clarity or optimization. So that time when we use logical CTU blocks, it would help in clarity and optimization. So these are some things we need to understand while using joins to optimize joins. Thank you.